Hello everyone. Today we are going to look at SWAT plus. Before we start with the exercise, let's first go through the downloading procedure for SWAT plus. We have to go to the swat.tamo.edu website first. Click on software and we get started with SWAT plus. There is a button here for download SWAT plus. Once you click on that, you'll find all the instructions for the installation. This software needs QGIS. The version that we need is also mentioned here. Install QGIS 3. So let's go to the web page first for the download for QGIS. Now here it says that we should select the long-term release repository. So let's go and find out where that is. So here is the long-term release repository, and we're going to download the 64-bit version. So let's see. Okay, the download has started. Okay, the other thing that we need is the SWAT plus tools installer. Again, the download link is given here. So okay, this download has also started, and there's also a SWAT plus model command line executable. You can download this for Windows from here, and if you're using Linux, then you can use any of these two links. Actually, we do not need to download the SWAT plus model command line executable, as it is already packed in the SWAT plus tools installer. Okay, once we are done downloading this, we can follow the instructions for installation as we proceed. First we will install the QGIS and then the SWAT plus installation. You can extract this and proceed with the installation by clicking on the SWAT plus tools installer. I already have them installed on my computer here, and to save some time, we'll proceed with the exercise. First, let us open QGIS. Once you open QGIS, go to plugins, manage and install plugins, and look for QSWAT. As we have already installed the QSWAT from the QSWAT plus tools installer, this has already installed a plugin for SWAT plus in QGIS. So now all we need to do is check on this plugin and close. Now this plugin would start appearing here under plugins, QSWAT plus, and once you click here, the SWAT plus window would open. Okay, now let's begin with the project setup. We click on a new project. We select a folder of our choice. For this exercise, I'm going to save my work on the D drive under the folder name of VAEN 673, and we select the folder. Now we are going to enter the project name, and the project name must start with a letter. I'm going to name them homework 8.2. The next step is watershed delineation. Before we start to delineate the watershed, we need to prepare the data first. We are going to load the DEM first. For doing that, we can go to layer, add layer, and add a raster layer. We can navigate to the folder where the data is located. For this exercise, we have already provided the data under the folder name exercise 7 data. I'm just trying to find that folder and import the data. Okay, this is the data that we need, the DEM, and I'm going to click the DEM and click on open and add it. This already has a coordinate reference system, so I'm just going to click OK and close it. So now the DEM is already loaded here. The next we are going to add a sub-basin outlet. To do that, we're going to layer again, add layer, and this time we're going to add a vector layer. In the vector layer, we are going to the outlet folder under exercise 7 data, and we click on basin outlet.shp. This is a shapefile. And again we click on add and close it. Now since the data is already projected in the right coordinate references, we did not have to do any extra work. But in case the data does not have the right projections, we need to project them first. And we have seen in the previous exercises how to do that in ArcGIS, and there is a very similar process in QGIS as well. With the current projection, the basin outlet is not visible in our map region, so we are going to reproject it. In order to reproject, we can double click on the basin outlet here, and we can choose a coordinate reference system. I'm going to set it as the same coordinate reference system as the project. This is called the project CRS, and we click on apply and OK. So now we can see that the outlet shapefile has showed up, and we can proceed from here. Okay, now we are going to start with the QGIS delineation of Watershed. So this is the step 1, delineate Watershed. We are going to use the dem.diff file which we have already loaded as the DEM file. It's asking you if it can use the same DEM as the DEM file for watershed delineation, and I'll say yes. So this is where the DEM is already selected. Okay.
The first thing that we need to do after selecting the DEM is to create a stream network. In order to do that, we have to select the channel threshold and stream threshold areas. For this exercise, we are going to set the channel threshold to 100 hectares. So first we're going to select hectares from here and then select 100. And for the stream threshold, we're going to set it as 1000 hectares. Notice how the number of cells vary in accordance with the area. We are going to manually select where we want the outlet of our watershed. In order to do that, we have to first select the location of the outlet. The outlet has been provided with the exercise. We have to first add a layer. It's going to be a vector layer since it's a shapefile that has been provided with the location of the outlet, and then navigate to the location of the outlet and click on basin outlet.shapefile and click add. Now we go back to the watershed delineation window and click on create stream. We'll wait for the streams to be created and then select a point on the stream that is closest to the outlet that we have already imported. Now that the streams are created, we are going to zoom in on the DEM to get as close to the watershed outlet as possible. Now we are going to draw our own outlet by clicking on draw inlet/outlets and clicking on top of this basin outlet shapefile and click OK. We can click on review snapped, and this would demarcate the outlet of this watershed. Now click on create watershed. Once this is done, we are going to create a landscape. We are first going to click on create and then go to buffer channels. We are going to use a buffer channel as a floodplain with a buffer multiplier of 10, which is entered by default, and click on create. Done. And this brings us to the end of our watershed delineation. We click on OK and let SWAT Plus construct the topology and all the necessary things that are required for moving on for the creation of HRUs. Next, we are going to create HRUs. That is step 2. Click on create HRUs We are going to use the land use and soil maps that are already provided with this exercise. So we're going to navigate to the folder where the land use is located. Click on land use and open it. Next, we are going to enter the land use table. In order to do that, click on use CSV file and navigate to the folder lookup tables. Inside lookup tables, you can find an Excel sheet called ALK underscore land uses. That is the land use for the watershed of the Elkhorn Creek. Click open. We do the similar thing for soil map. Navigate to the soil folder and click on soil. And again for the lookup table, we're going to use a CSV file. Go to lookup tables and click ELK underscore soils. Now we are going to use the StatsGo database for this soil information. Next, we are going to set the slope band, and we are going to select the floodplain that we have already created using the buffer method. We select the buffer flood 10.tif and then set a percentage of the subbasin. So we're going to set here a 5% threshold for short channel merge and then click on read. Once this is done, we are going to select the dominant HRU from here and click on create HRUs. There is a message that pops out saying fail to generate aquifer shapefile. Aquifer result visualization will not be possible. We click on OK, and this is not an error. We can proceed with this. This brings us to the end of step 2, that is creating HRUs. Now we are going to step 3, where we will edit inputs and then finally run SWAT. Click on edit inputs and run SWAT. This opens up a new window, which is the SWAT Plus editor. We are going to import the QSWAT Plus project into the SWAT Plus editor. We click on start import. Now proceed to edit SWAT Plus inputs. Here we are going to use weather generators and weather stations to define the weather patterns in our watershed. Click on weather generator and click on import data. Since we are using observed data, we are going to check on using observed data section here and then click on start import. These are the list of weather stations that are available in the area. Now we are going to the section weather stations, where we are going to import our observed weather data. To select our own observed weather data, we have to browse to the directory where we have the weather data. This is also provided with the exercise. Navigate to the folder weather and select folder. The directory to save your SWAT plus weather files is the default, which is inside the scenarios folder, and now we click on start import. This creates a record for our weather station for which we have provided the observed data. Now we are going to simulation options. Click on time and set the necessary set the options here. We do not need to change anything with here. Next we are going to the print option. Here we change the warm-up period to 0, and here we have to select what options do we want to print as a part of the output. We are going to deal with the monthly options, so we are going to uncheck all the yearly buttons here. And since we are going to compare stream flow or water yield, we are going to select only the basin outputs. So whatever starts with basin underscore, we are going to check on the monthly section. Okay, and now save changes. Next we are going to write the inputs. Click on save and write input and then start writing files. Now click on run model and then run SWAT plus. Once the model is run, click on analyze model output and click on import output and then start importing output. Now that the output has been imported back to QSWAT, you can exit the SWAT Plus editor. A fourth option has popped up which says visualize. This will help us visualize the output and compare the simulated and observed data. Click on visualize and select the plot button. We have to choose SWAT output table. Before moving on, I would like to point out one thing, that SWAT Plus is still under development and there are a few glitches in the code. As of now, the stream flow calculation is not working fine, and hence we are going to avoid the stream flow part and we are going to move on with water yield. Now we do not have any observed information for water yield from a watershed, and hence we are going to convert the observed stream flow data into water yield by taking into account the area of the watershed. We have already provided the data as a part of the exercise. So what we are going to compare here is water yield from the basin. So we are going to select basin WB month, which stands for monthly basin water balance, and choose the observed data file. As I mentioned, we have provided observed data, so we can navigate to the observed folder and choose observed_yield file. Now we have to select the unit number, which is 1, and the variable name, that is water yield, and click on add plot to add the plot for the simulated data, and click on add observed to add the plot for the observed data, and click on plot. I'm going to save the name of this plot as plot 1 and click on save. And here we have the plot for the measured versus observed water yield. We also have the table for the simulated and observed yield, along with the Pearson correlation coefficient here and the Nash-Sutcliffe coefficient. As you can see, there is not a good match between the observed and simulated, and hence we need to do a bit of calibration on the model. In order to calibrate the model, we have to go back to step 3 again and do some changes in the edit inputs and run SWAT segment. We can simply continue to the editor because there is no new changes to the project. Click on edit SWAT plus inputs. For this basin, we have identified a few parameters to be changed in order to do a preliminary calibration. Navigate to basins and then codes. Click on crack flow code and change it to model crack flow in soil. Go down and click on save changes. The next thing that we are going to change is the soil properties. Click on soils, and then individually change the properties. Change the hydrologic group from B to C, and the potential or maximum crack volume of soil profile expressed as a function of total soil volume from 0.5 to 0.05, and click on save. Now go back and do the same for the other 3 soil types. Next, we need to go to hydrology. Click on hydrology and then edit multiple records. We need to change the value of soil evaporation compensation factor, or ESCO, and we're changing the value from the default value of 0.95 to 0.1, and then we are applying it to all the HRUs in the basin. And now click save changes. Now we need to rewrite the input file. Click on write input files and then save and write files. Start writing files. Now we need to rerun the model. To run model and then run SWAT plus. Close it. Next, we analyze the model output and click on import output and start importing output back to QSWAT plus. You can exit SWAT plus editor now. Click on visualize again. Click on plot. We again select basin WB month. Select the unit 1 and variable water yield. Notice that the observed is already loaded. Click on add plot and click on add observed. Now we're going to plot again and name it plot 2. This time we have a better result. We have a positive Nash-Sharp cliff as well as a positive Pearson correlation coefficient. However, this calibration is very preliminary and may not suffice as a full-term calibrated model. With this, we come to the end of the exercise. Hope you all enjoyed learning SWAT Plus with me. Thank you.